Hello children, today we are going to talk about amines. It's a very small chapter in your chemistry syllabus carrying a weightage of approximately 4 marks. Let's talk about what are amines. When we talk about amines, they have the general functional group NH2. This is called amine or it's called amino group. And we have amines as derivatives of ammonia. They are called derivatives of ammonia. What does this mean? Now when we say they are derivatives of ammonia, everyone knows what's the formula of ammonia. It is NH3, and in NH3 we can see that there are 3 hydrogen atoms, and if we remove the hydrogen atoms, like the first hydrogen atom, if I remove from ammonia, I'll put an alkyl group over there, or I can put an aryl group. What's the meaning of aryl group? We all know it means it is going to be an aromatic ring like benzene. For example, we have aromatic part like for example benzene. If you have an aromatic part attached to the nitrogen, then that becomes an aromatic amine, and if you have an alkyl part attached, that becomes your aliphatic amine. So in this particular amine, the formula which we have drawn here, it's a kind of primary amine, which means that one hydrogen atom has been substituted by a carbon atom. So you will be having only one alkyl or aryl group attached. In the case of secondary amine, we will have 2 alkyl groups or aryl groups attached to nitrogen atom. And finally, when we talk about tertiary amines, then we will have all the 3 hydrogen atoms of ammonia being replaced by an alkyl group or an aryl group. So this was the first classification of amines into primary, secondary and tertiary, depending upon how many carbon atoms are attached to nitrogen atom. If you have 1 carbon atom, then that's called as a primary amine. If you have 2 carbon atoms attached, that's called a secondary amine, and if you have 3 carbon atoms attached, then it's called a tertiary amine. So this was the simple classification of amines. Then we talk about the second classification of amines, that is simple amines and mixed amines. The second classification of amines is based upon the type of alkyl group attached. The type of alkyl or aryl group attached. Now this kind of classification is going to be applicable for tertiary amines. If you have a tertiary amine like this, that is nitrogen atom attached to 3 carbon atoms, which means tertiary amine, and all the 3 alkyl groups, all the 3 groups are similar, then that's called a simple amine. So we're going to call it a simple amine. On the other hand, if all the 3 alkyl groups are different, then that's called a mixed amine. So this is the second classification of amines based upon the type of group. This is only for tertiary amines. So this was the basic introduction of amines. Let's talk about their geometry. Now if you look at this structure of amines, it has got 3 bond pairs, and also children, we know that there is a lone pair over here. So naturally we have total 1 lone pair and 3 bond pairs, which makes up 4 pairs of electrons. 4 means we are going to have a tetrahedral geometry. Alright, we have a tetrahedral geometry, which means that the bond angle has to be 109 degrees 28 minutes, right? So the bond angle, we can say, should be 109 degrees 28 minutes. But frankly speaking, this bond angle is going to deviate from 109 degrees 28 minutes to 108 degrees. So there is a little change in the bond angle. The bond angle has got reduced because we can see that there is a lone pair which is occupying so much of space, and it is going to be negatively charged. So this negatively charged cloud of electrons is going to repel this electron pair as well as this electron pair. So there's going to be lots of push from the top, there's going to be a lot of repulsions from the top. So they will say that there's lots of lone pair bond pair repulsions, which makes the bond angle, this bond angle we're talking about, this bond angle, which makes the bond angle deviate from ideal bond angle to a smaller bond angle. So this can be a question for us in the exam. What is the geometry of the amines and what is the shape of amines? So when we talk about geometry, we have to calculate, count all the pairs of electrons. So it's 4 pairs, so it's tetrahedral geometry. It's tetrahedral geometry. And when we talk about the shape, in case of shape, we have to just take into account the bond pair of electrons, which are 3. You can see this is first bond pair, second bond pair and the third bond pair. So this, by looking at it, the shape becomes pyramidal. Alright, so this is the shape of amines, pyramidal, and the geometry is going to be tetrahedral and the bond angle is going to be less. Let's talk about the nomenclature of amines. So we have common name as well as the Iupac name for every organic compound. In common name, we are going to call amines like alkyl amines, and in the Iupac name, we are going to call them as alkane amines. Alkane, we are going to remove this E, alkane amines. Okay, so that's going to be alkane amine, or in the common name alkyl amine. Let's take some examples and understand it in a better way. We'll start with the simple examples. CH3NH2 is the first example. So when we talk about this compound, it is a derivative of methane. As we all can see, it is CH3. It was CH4 first, and we have removed one H and we have substituted amine group over there. So in the terms of common name, it's going to be methyl amine. And when we talk about the Iupac name, it's going to be methane amine. Methane. And mind well, we don't have to write the E, okay? So we'll write methane amine. So that's my first compound, which was not very difficult. We go to the second one, CH3, CH2, 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 NH2. We have directly jumped to the third one. So this compound has got 3 carbon atoms. So it's a straight chain. So we'll be calling it as N-propyl amine in the common name. And when we talk about the Iupac name, then we can call it as propane amine. Let's talk about 1, 2, 3. Look at this. So when we look at this next compound, which is isomer, a chain isomer of the previous compound, it can be called as a position isomer, sorry, not a chain isomer, because we can see that the position of amino group has changed from position number 1 to position number 2. So this kind of compound, we all know it's called as isopropyl. So this is going to be your isopropyl group. This complete thing is going to be an isopropyl group. So we can call it as isopropyl amine. And then we have the Iupac name. In case of Iupac name, we'll be calling it as 1, 2, 3. So at position number 2, you have got amine. So we'll call it as propane dash 2 dash amine. Alright, so this is the way we are going to put dash prior and after the digit. Let's take some more examples. This compound now we are going to see. So the nitrogen is attached to 2 carbon atoms. So this is a secondary amine. And when we talk about the common name, we are going to see the alkyl groups. Number 1 is methyl and number 2 is ethyl. So alphabetically we'll be writing ethyl first and then methyl. So it's going to be ethyl methyl amine as the common name. Let's look at this. This is a tertiary amine because the nitrogen is attached to 3 carbon atoms, 1, 2, 3. So it's a tertiary amine. And alphabetically this is methyl, this is ethyl, and this is 1, 2, 3. This is propyl. So alphabetically we are going to place it as E and then M and then P. So we can call it as ethyl, methyl, and then we call it as, this is a straight chain, so it's N-propyl basically. So we can write it as N-propyl amine. Look at this. This is also tertiary. 1, 2, 3. There are 3 carbon atoms attached. This is methyl, this is ethyl, and this is also ethyl. So we can just call it as diethyl, 2 times ethyl, right? We have 2 times ethyl. So we'll just say diethyl, then methyl, and amine. So this is the way we are going to write the names of these compounds. It's very simple. Just practice the compounds which are given in the textbook. They are most important for you from the examination point of view. Now let's talk about the Iupac name. For the Iupac name, we are going to select the longest chain. So over here, the longest chain of course is going to be this chain because it contains 2 carbon atoms, and this one, if I consider this one, this is only 1 carbon atom. So we are going to take that chain which has got the maximum number of carbon atoms, and it should contain the nitrogen also in it. So this is going to be my longest chain. Look at this. Same way for this compound, if you see 1, 2, 3, 1, 2, 3. So this is containing 3 carbon atoms. This is 1, 2, this is 1. So I am just going to put the longest chain in this boundary. Similarly, look at this. This contains 2 carbon atoms, this contains 2 carbon atoms, this contains 1 carbon atom. So the longest chain will be the one which contains 2 carbon atoms. So first point is to understand that which is the longest chain, and then start numbering it and labeling it. Like for example, this is the first carbon atom, now first position now. This is the first position. So we'll just call it as N. N, what have you got at N? You've got CH3 at N position. This is called N position. So N methyl. So we'll call it as N, capital N, then we'll say methyl, and then we talk about what is this? This is 2 times ethane, that means. So we'll say N methyl ethanamine. N methyl, N ethyl. Now that's going to be alphabetically. If you say N ethyl, at nitrogen, what was attached? Ethyl was attached. At nitrogen, there was also one more methyl attached. And what is the longest chain? It's 1, 2, 3. It's propanamine. Propanamine. When we talk about this last compound, again this is N-methyl, N-ethyl. So alphabetically, it's going to be N-ethyl. Alphabetically means what? We are going to take E first. N-methyl. That means we're going to take M after that, and the parent is your ethane. The parent is ethane, right? So we are going to say ethane amine. So these were some of the compounds. I'm sure you have got some fair idea about how to name these compounds. There are some more compounds in your textbook. Please go through them. That's important. And similarly, we can also talk about some of the aromatic examples. I'll take some compounds of aromatic. Let's begin with the simplest aromatic amine, that's benzene with NH2 attached. So whenever the amino group is attached to benzene or any aromatic compound, that's called aromatic amine, and this is called as aniline in its common name as well as in its Iupac name. So this is not only the common name but also the Iupac name. There's one more Iupac name. We can write it as benzene amine. So the name of this compound is going to be benzene amine. Generally, we are going to use aniline in most of our discussions. Then we can take some derivatives of aniline like NCH3H. So of course, this is going to be my parent compound, right? So we'll be calling it as N-methyl. Let's take Iupac name. This common names are not important. So we'll just take Iupac name, okay? So it's going to be N-methyl parent, aniline. Somebody can have CH3, CH3 2 times. So that's going to be NN dimethyl aniline. Alright, so these are some of the compounds which are there and they are quite important for examination point of view. Then when we look at this is also a very familiar compound, common compound. So if you see, look at this. In common nomenclature, its name is orthotoluidine. You know, this common name is also important. Now this toluidine is very important for exam. So it's called orthotoluidine. Similarly, we can have metatoluidine if NH2 comes at the meta position. Similarly, we can have para-toluidine if NH2 comes at para position. In terms of nomenclature in the Iupac system, we can call this compound as toluene, and we'll say 2-amino toluene is the Iupac name, right? 2-amino toluene is going to be the Iupac name. So these were the compounds which we have discussed, few compounds which we have discussed. For better understanding, please solve all the exercise questions and the formulae which are given in the book. We'll see the next topic in the next class. Thank you so much. Take care. God bless.